Hello dear physics students, respected teachers. So today I am going to discuss a very important topic from liquids, that is known as surface tension. Surface tension. So first of all, what is surface tension? To understand definition of surface tension, suppose we have a liquid in a tub which is free and at rest, and if we put a needle just at the top of the free surface of liquid at rest, needle doesn't sink immediately, but a depression is created just below the tip of the needle. It means free surface of liquid at rest behaves like skin, like elastic membrane. And this property of liquid, due to which free surface of liquid at rest behaves like an elastic stretched membrane or skin, is known as surface tension. Now, what is the cause of surface tension? For that, we have to consider molecular theory of surface tension. Molecular theory of surface tension. To understand molecular theory, suppose we have a tub containing water. Let water is free and at rest. Then suppose a molecule A well within the liquid, inside the liquid. Then this molecule A is attracted equally in all directions. It means net force acting upon the molecule is zero. So this means this molecule A is free to move anywhere within the liquid. Molecule is free. Such forces which act between similar molecules are known as forces of cohesion. So you have to understand some terms to understand molecular theory. Force of cohesion, force between similar molecules, like force between water molecules. Then force of adhesion, force between dissimilar molecules, that is force between glass and water molecules. Then there is molecular range. So molecular range means, so this particle is attracted equally in all directions. It means in the space surrounding it, its effect can be felt. So the maximum distance from the center of molecule up to which its effect can be felt is known as its range, and it is known as molecular range. And if we draw a sphere taking molecule at the center and radius equal to molecular range, and that sphere is known as sphere of influence. So these are certain terms that we should understand. Molecular range means the maximum distance from center of molecule up to which its effect can be felt. Sphere of influence means it is a sphere drawn taking molecule at the center and radius equal to molecular range. And force of cohesion means force between similar molecules like water molecules, and force of adhesion means force between dissimilar molecules, force between glass and water molecules, force between chalk and board. We can write on board with the help of this chalk due to force of adhesion. Now, since this molecule A is free to move within the liquid volume, because it experiences no net force, as it is attracted equally in all directions. So no net force is acting upon this molecule A, and all other molecules will lie well within the liquid. So take another molecule B, so that a part of its sphere of influence lies outside the free surface of liquid, that is PQ. Then this sphere of influence has more molecules in the lower half than molecule in the upper half. So it means this molecule will experience net downward force. Then consider the third molecule C, which lies just above the surface of the liquid. Then upper half of sphere of influence is totally empty. It means this will also experience downward force, but this force will be maximum. It means three molecules ABC under different situations. Molecule A doesn't experience any force. It is free to move anywhere. Molecule B experiences net downward force. And molecule C experiences maximum downward force. So it means if we draw a plane RL parallel to PQ surface, which is free and at rest, that is at a distance equal to molecular range, that is distance between PQ and RL layer, you can say, is equal to molecular range. It means it is very clear that all the molecules lying between PQ and RL will experience net downward force, and this force increases as we move up and becomes maximum at the top. This region is known as surface film. The surface film is that layer above the surface of liquid, just above the liquid, in which all the molecules experience net downward force, and this force increases as we move up and becomes maximum at the top. It means if we take molecule from below, say a molecule, into the film, work has to be done against downward force. Work has to be done against downward force. It means all the molecules, and that work done is stored in the film as its potential energy. It is all the molecules lying within the surface film will have more potential energy than the molecules lying below it, because work has to be done in order to take molecule from below into the surface film, because as soon as it enters the surface film, net downward force starts acting, and which increases as we go up. This work done is stored in the film as its potential energy. So it means potential energy of all the molecules within the film is more than the potential energy of the molecules below the film. And for stable equilibrium, for stability, potential energy should be as least as possible. So to have minimum potential energy, the molecules in the surface film, that is top molecules, always attract each other on the surface of the liquid. Because of this molecular attraction, free surface of liquid at rest behaves like an elastic or stretched membrane. So it means this is intermolecular force. Every molecule attracts other molecule to have minimum potential energy, and while attracting each other, they tend to have minimum surface area, because minimum surface area is needed to have minimum potential energy. So least is the surface area, least is the potential energy. That's why free surface of liquid at rest behaves like an elastic or stretched membrane or like skin. And this is the cause of surface tension. That is, intermolecular forces is the cause of surface tension of the liquid. Clear? Okay. Then there are some applications of surface tension. First application, you can see why small raindrops are spherical and big raindrops are elliptical in shape. Because for a given volume, surface area of sphere is least possible. That's why small raindrops acquire spherical shape only. But when the size increases, so gravitational pull dominates. That's why it becomes elliptical. So this is due to surface tension. Why small raindrops are spherical in shape. due to property of surface tension of liquid. For a given volume, surface area of sphere is least possible. That's why the small raindrops acquire less spherical shape. Then, second, you can take example of painting brush. When a painting brush is dipped into water completely, all the hairs of brush get separated. But when it is taken out, all the hairs are covered by an elastic stretched membrane. This is again due to property of surface tension. All the hairs are held together and they have been covered by an elastic stretched membrane due to property of surface tension. Third example, you can take practical example. Take a wire frame with handle, dip into soap solution. Dip into soap solution means so soap film is formed on this circular surface. Then take a wet thread and put the wet thread in any closed shape. Then there is molecule-molecule attraction. So molecule attract each other, but it has any closed shape. Then take a hot needle and then remove the film from inside this loop. You will see this wet thread acquires a circular shape. This circular area is maximum because this area of the film will tend to have minimum surface area. Force due to surface tension is acting tangentially to the surface of the film. That's why you'll see after removing film within this area of the wet thread, it acquires circular shape due to property of surface tension. That is, the surface of the liquid which is free and at rest always tend to have minimum surface area. This is the main property of surface tension. Then, how we can measure surface tension mathematically? Suppose we have any surface area which is free and at rest, top of the surface of liquid, say this one, which is free and at rest. Now, draw an imaginary line AB on this surface area, imaginary line. And we have already proved due to intermolecular forces, each molecule on this left side of the line attracts molecule on right side everywhere on this line. It means a tangential force is acting between the molecules on this line AB. So this tangential force acting per unit length is the measure of surface tension of the liquid mathematically. So tangential force acting per unit length is called surface tension. So sigma is equal to F upon L, or F is equal to sigma into L. So sigma stands for surface tension. So surface tension is defined as the tangential force acting per unit length on an imaginary line on a free surface of the liquid at rest. Units of sigma will be Newton per meter in SI system, dyne per centimeter in CGS system. And cause is very clear. Intermolecular forces is the cause of surface tension. Then we define surface energy. Another formula for surface tension. Now, suppose a rectangular wire frame PQRL having a movable arm AB which can be moved. Dip this frame into soap solution so that soap film is formed. Now, this soap film has two free surfaces on both sides. Force due to surface tension acts like this, inwards on every side. That is F is equal to sigma into L by definition. This is the force acting due to surface tension. Now, since there are two free surfaces, sigma L upper side, sigma L lower side, it means if we have to move this movable arm AB through certain distance, then double force is needed to move it. So force required to move the movable arm AB from AB to CD, say, through distance x. The force required is F dash equal to 2 sigma L. So as force is required, so work has to be done. So work done in order to move the side AB from AB to CD through distance x is given by W is equal to F dash x or 2 sigma L into x. But 2 L into x, L is the length of this movable arm, x is the breadth, then length into breadth is the area. So total area will be 2Lx. So total increase in area when this movable arm AB is moved from AB to CD through distance x is given by 2L into x. So therefore work done is equal to sigma into A. So this work done is stored in the film as its potential energy. So this is called potential energy of the surface film. So therefore potential energy per unit area is equal to sigma, and this is called surface energy of the film. So surface energy of the film is nothing but surface tension of the liquid. So in other words, potential energy required to increase the area by unity or work done required to increase the area by of the film by unity is equal to surface tension, and surface tension is numerically equal to surface energy. So this is all about surface tension and surface energy. So be happy, clear. I think this surface tension topic is very important and very interesting. So I think you have clear all your doubts. So be happy, all the best. Sarbat Dapala.